2015 Legal and Higher Level Question 8 Probability question, which was worth 65 marks, which was more than 20% of the paper. It's a basketball game where Michael is taking free throws. The probability of success on his first one is 0.7. So I'm just going to write beside this, the probability of being unsuccessful will be 0.3. For subsequent free throws, it's 0.8 if he was successful on the previous one, and 0.6 if he was unsuccessful on the previous one. So part A, find the probability of success with the first 3 throws. So for the first one, 0.7. For the second one, he has been successful, so it's this 0.8. And again, 0.8. And these 3 multiplied is 0.448. Find the probability unsuccessful with first 2. Okay, well that's my 0.3. So unsuccessful, 0.3 multiplied by. So he was unsuccessful on the previous throw. So the probability of success if he was unsuccessful is this 0.6. So the opposite side of that is 0.4. He's been unsuccessful on the previous. He's unsuccessful again. 0.4. And then successful with the third. He's been unsuccessful. So successful with the third brings in this 0.6 here. And 3 by 4 by 6 is 72. So that's equal to 0.072. Okay, part C. List all the ways he could be successful with the third. Okay, successful with the third is success. He could be unsuccessful or successful with the previous one. And similarly, he could be unsuccessful or successful with the previous one. And we have to do the opposite of these then. So it will be SU. We don't have USS. And it would also be a U and an S. We don't have SUS. So it's the four options. So successful with the third one. You can see then there's this and this are the only other possibilities for the first 2. So find the probability he's successful with his third. Well, we need to multiply these out then and find the values. Now we've already done 2 of them. We've done, this is SSS and this is UUS. So we have these 2 done, SSS and UUS. So the probability of unsuccessful, successful is that it's going to be 0.3, which we had before. And then he's unsuccessful, and then he's going to be successful. So 0.6, let me just double check that. No, it's 0.6 if he was unsuccessful. And then if he was successful on the previous, it's 0.8. So this is my 0.8. 0.3 by 0.6 by 0.8 is 0.144. Successful at the beginning. So this SUS, success at the beginning, is 0.7. First throw, this 0.7. To be unsuccessful, having previously been successful. So if he was successful, it's 0.8 that he'd be successful again. So the opposite side of that we haven't had yet is 0.2. So he got one, and then he misses the next one. That's 0.2. And then to get one having been unsuccessful on the previous one is back to this 0.6 here, the same as this one here. So 7 2s are 14 by 6 is 84, so 0.084. And if we add these 4 together, these 1, 2, 3, 4, 1 plus 2 plus 3 plus 4 together, we're going to get 0.748. Okay, part D. Let Pn be the probability that Michael is successful with his nth free throw. So Pn is success. And hence 1 minus Pn is unsuccessful with his nth, show the probability of, now this reads as the probability of success on his nth plus 1 free throw is 0.6 plus 0.2 pn. So what are the ways he can be successful on his n plus 1? There's the success. So he could have been unsuccessful previously or successful. So it's these two probabilities added together will give us, well, hopefully will give us this right hand side. So unsuccessful, Pn is success. So this S is Pn. So we do this one first. So that's Pn multiplied by he was successful on the previous one. So we know that this 0.8 again, this is the one we're looking at, 0.8, he was successful on the previous one. So Pn by 0.8, we'd have to add unsuccessful on his nth, this unsuccessful they've given to us here, 1 minus Pn. And then he's successful on his next one. So we'd have to multiply that by, is it 0.6 if he was unsuccessful. It's this 0.6 here again. Unsuccessful and then successful by 0.6. So this is equal to the probability of success on his nth plus 1, or the one after the information that we've been given. So we have 0.8, if you just imagine Pn as a number, then we have this 1 by 0.6, so it's plus 0.6, and then minus Pn by 0.6 is minus 0.6 Pn. So that's just going to give me 0.8 minus 0.6, 0.2 Pn, plus 0.6, which is what they asked us to show. Assume that P is Michael's success rate in the long run. That is, for large values of n, we have Pn plus 1 approximates to Pn and approximates to P. Using the results from D part 1, this one here, show that P is equal to 0.75. Okay, well, so the unknown we have here is this Pn. And we're told that approximates to P and approximates to Pn plus 1. So this Pn plus 1 here, we can replace with the unknown that we have as Pn. So we can say instead of Pn plus 1, that approximates to Pn, and they're both equal to 0.2 Pn plus 0.6. So if I bring the 0.2 Pn to the left, I'm going to have a full one take away 0.2. So I'm going to have 0.8 Pn equals 0.6, and dividing by 0.8, I get Pn is equal to 0.6 over 0.8, which is the same as 6 over 8, which is 3/4, which is 0.75, which is what we're asked to show. Okay, this is where it goes into a geometric sequence. So what knowledge do we have about a geometric sequence? So we have term 2 over term 1 will be equal to term 3 over term 2, and so on. That will give us our common ratio within a geometric sequence. And we're actually given the ratio here, an plus 1 over an. So an plus 1 over an, where an is equal to this guy. So an plus 1, n changes to n plus 1. So the top becomes p minus pn plus 1. And the bottom stays as p minus pn. So what did we have for p? P is 0.75. And we had pn plus 1 up above. We were asked to show that it was equal to this 0.2 pn plus 0.6. So 0.2 pn plus 0.6. And on the bottom, we just have 0.75 minus Pn. So we tidy this up. We're going to have 0.75 minus 0.2 Pn minus 0.6 over 0.75 minus Pn. So on top, we're going to have 0.15 minus 0.2 Pn. So we're going to have to factor out this Pn to get it. They wanted to show it's a fifth, and you can see there's a relationship between 15 and 75. That's 1/5, 15 over 75. So if I factor out a fifth, they've told us the answer is 1/5. So what do I have to multiply 1 by to get the top line? Well, just itself. And does that work for us on the bottom? It's 5 times 0.15 minus 0.2 pn. Is that equal to the bottom? 5 0.15, 5 by 0.15 is my 0.75, and 5 by 0.2 is 1. So yeah, they do factors out for us, so we can cancel these. So there's term 2 over term 1, or any term over the previous term, pn plus 1 over pn is equal to a fifth. The smallest value of n for which p minus pn is less than 0.40 and a 1. So an is equal to a geometric sequence p minus pn. So an is equal to p minus pn, and an is a geometric sequence. So what is my geometric sequence? A or to the power of n minus 1. So we need a, which is the first term, so a1. That's my first term of this sequence, p minus p1. So I need my probability of success on the first one, which I can't remember. What was the probability of success on the first one? 0.7 was the probability of success on the first one. And we know that p from above, we got p to be 0.75, didn't we? Yeah, we got p to be 0.75. So I'm going to have 0.75 minus 0.7 is the my first term, 0.05. So I have, well, we can call that 1 over 20. Let's call it 1 over 20 because we have the ratio as 1 over 5. So if I fill this information in here, we have 1 over 20 by 1 over 5 to the power of n minus 1. And we're asked to show when is that less than 0.0001. So this is logs, isn't it? I'm going to start by multiplying by 20. So I'm going to get 1 over 5 to the power of n minus 1 less than, and if I multiply that by 20, I get 0.002. So I'm going to have to go to the right here. So n minus 1 by the log of, actually I'll change it to a decimal now, 0.2 has to be less than the log of 0.0002. So I need to divide across by the log of 0.2. Now just on your calculator, that's going to give you a negative value. So if I divide across by the log of 0.2, we know if we divide by negative with these inequality symbols, we're going to need to reverse the sign. So greater than from less than, 3 noughts and a 2. Divided by the log of 0.2, and on a calculator this is going to give me 5.29. So bringing the 1 across, n has to be greater than 6.29, and n, I think they told us we're all natural numbers, so n will be equal to 7 in this case. You arrive at a game Michael is playing. He's already taken many free throws, but you do not know the pattern of success. Based on this knowledge, what is your estimate that the probability that Michael will be successful on his next free throw? Well, we worked out earlier that p was equal to 0.75 in the long run, so that has to be the answer here. And the final part is, why would it not be appropriate to consider Michael's subsequent free throws as a sequence of Bernoulli trials? Well, what we know about Bernoulli trials is the probability of success and failure doesn't change. So in this case they do. So we could write that, or we could just say that another way to say that is the events are not independent. Not independent. Probability of success and probability of unsuccess not consistent. Or probabilities change. So therefore not Bernoulli. So a tricky enough probability question, definitely considered one of the harder ones that's been asked in the project maths era. A question well worth practicing though, because if you've practiced this question, when you get these unusually phrased questions, they won't throw you.